The diagram shows a heating curve for a sample of compound X. Is X solid, liquid, or gas at 20? So we know that AB is going to be a solid, CD is going to be a liquid, EF is going to be a gas, and we know that BC is going to be melting, and DE is going to be boiling. All right, so it's asking here what's going to happen at 20 degrees C. So where is 20? 20 is above 15 and of course below 18. So it's somewhere about here. So at this stage, what's the state of this matter? It's going to be a liquid, right? It's above melting point, so it's for sure going to be a liquid. Everybody gets this. Now, the second equation is where people usually don't get it. And we will study about equilibrium next in chapter 7. But it's asking here an equation for the equilibrium that exists in region BC. So BC is basically melting, where we have a solid changing to a liquid. Now, now the compound is X, so you're going to write X and then X in a solid form. So you're going to write it a small X between brackets like this. And then that becomes X in a liquid form. So it's going to be X in a liquid form. All right. Now, equilibrium means that it's changing from solid to liquid and from liquid to solid at the same time and all the time. Solid to liquid, liquid to solid, solid to liquid, liquid to solid, all the time. Now we call this equilibrium because it's happening at the same time and at the same rate. So the sign to show equilibrium, or like this change that goes backward and forward, is half an arrow going forward and half an arrow going backward. We call this the reversible reaction sign. Name the change of state which occurs in region DE. So DE is basically boiling. And so you write here boiling. Now it can be condensation, although condensation is like the other way around. And what we have here is a heating curve and not a cooling curve. If it was a cooling curve, then we would say condensation, but both are accepted. Now here's the thing. If you write evaporation, you lose the mark, because in DE, it's only boiling because that's your boiling point. It's at 80 degrees. Evaporation happens at all those points. It happens at 16 degrees C, 17, 18, 19, all the way until 79 degrees C. All right, so that's evaporation, anywhere between 16 and 79. At 80, it is not evaporation anymore. It is boiling. All right, so I take away a mark if you write evaporation. Sorry, guys. Okay. Explain how the curve shows the curve. Okay, it's not asking about the temperature. Guys, please read the question. Okay. Explain how the curve shows that a pure sample was used. Now, the reason I know this is pure is that this line of melting is sharp and horizontal. It is horizontal. It's not crooked. It's not looking like this. And then this line is same thing. It's horizontal. It doesn't look like this. All right. So that's how I know that it is pure. So you're going to say that line BC, which is melting, and line DE, which is boiling, are straight lines and horizontal. And you're going to say that pure substances have sharp melting and boiling point, and since it's horizontal, it means it's sharp. Okay. Now, if you write melting point decrease and boiling point increase, sorry guys, you lose the mark. Okay, because it's not asking about what happens to temperature, melting and boiling points, like points or values. It's not asking about the value. It's asking about the curve. How does it tell you that it's pure? All right.